Hey everyone, today we're gonna be doing a Leetcode question which is binary search tree to greater sum tree. So we are given a root of a binary search tree. We asked to convert it to a greater sum tree such that every node's value, or you can say every key of a original binary search tree or BST is changed to a original key plus sum of all the numbers or all the values or all the keys greater than the original BST keys. Okay. So they have asked us like, okay, you remember, like as a reminder, is saying a binary search tree follows a property like every left subtree, like every left value of a subtree should be less than equals to a node of a tree. Similarly, all the right subtrees should be greater than equals to the key value, and both left and right must be a binary search tree. Okay. Similarly, like it is saying like it should follow a property if it is a given as a binary search tree. Okay. So in this question, like this is a example, we'll do it one by one. Okay. Let's see the constant. They're saying number of nodes inside that binary search tree will range from 1 to 100, and the value inside that node will also range from 0 to 100. All the value inside that tree is also unique. So let's see like how we can do this question with some example. So I'll take the first example itself. Okay. So for now, this is our example. So we are given some binary tree, binary search tree. Okay. So this is a BST, binary search tree, where every value of a node, like every left value of a node should be less than equals to the left subtree. Similarly for right. So every number coming left to it should be smaller. So if you see all the numbers 0, 1, 2, 3 is smaller than 4, and all the number coming right like 4, 5, 6, 7, 8 is greater than 4. So in this question they have asked us like, okay, we need to change every node's value such that it should be the summation of all the number coming maximum, like number coming maximum to this, like number is more than this number, so it should include all those numbers. So if I say, okay, this is the highest number, it does not require anything need to be summed up. For this example, like for this particular node, okay, I have one value 8 which is greater than 7. For this I have these three value greater than 5. For this I have entire right tree as greater value, so I need to sum up with the original number. For this particular, the leftmost child, I'll say for the leftmost child of a tree, every tree, or you can say every subtree of a right, like parents right tree, parents subparents, you can say ancestor and all, it should be sum up over this number. So if I say every brute force idea, like okay, for every node I can do a DFS and I can store all the number greater than to it, like every number which is greater than 0 should be summed up to this node. Okay, for each node, like for this I'll do a DFS on the right side and I'll sum up all the number and I'll include it to this particular node. So that will be like very much time consuming, like there will be n nodes, and for every nodes we will be doing a DFS which will also be taking order of n. So it can be like n square time complex. So like it's very large. Like it can be working over here because the size is bit small, like it is only from 1 to 100, but sometimes it can also give a TLE. So what we exactly need to do, like what we are finding here. So they are saying, okay, every for every number, for every node, all the number maximum, you can say greater than this number, like root number, should be summed up. That means the number coming here will be same. Like the rightmost child will have the same value because nothing will be coming more than this. So if I say, okay, every time when I'll say, okay, here I will be passing nothing, but after returning from here, I will be like I will be sending my own value. Sometimes like you can think of this. Okay, for this nothing needs to be sum up because this is the largest value. For this is the largest value. I need to be summed up. Okay, so for this it will be what 8. It will be like 7 plus 8. It will be what 7 plus 8 plus 6. For this also it will be 6 plus 7 plus 8 because like it need all the number coming greater than to its original number. So if I say what we can do, I need one more thing. Okay, what I need, like okay, from here I know I need the rightmost, you can say, for this particular subtree, I need my entire right subtrees sum to be sum up over here. For this also, if I say, okay, for this amount, I need all my right subtree data to be summed up. Okay, but what if this is a left subtree? How am I going to include all this number coming to here? Like if I say, okay, what is the number greater than 5 in this subtree? I don't know, like I have only right pointer and the left pointer for each of the child. I cannot go to the parent child. Okay, so what I can do, like, okay, I can pass my, you can say, the upcoming value. So okay, for starting from here, I will not be passing some value, but it will be giving me just some returning value from the right. Okay, similarly it will be receiving some value from the top, from the parent, and it will be returning its own value if it is having a left right child. For this example, okay, so if I say it will be returning me 8, it will be returning me 8 over here. So let's say like this returned me what? This returned me 8. Okay, now number become what? 8 plus 7. So here number become 8 plus 7, which is 15. Okay, so this will return me 15 from here. This returned me 15 from here. Now, if I say this number will become what? This will number will become 6 plus 15. Why? Because I need all the all the child of the right side to be summed up. Okay, all the maximum number. So if I say, okay, if I'm doing 6 plus 7 plus 8, which is like here 15, so I will be saying, okay, 6 plus 15 will be what? It will be 21. Okay, so now this value become what? 21. So for now, this value have been chopped up to become 15. Okay, we have made this value as a 21. Okay, now I need this to be stored over here. That means I need to pass some value from the parent as well. For this, it does not have any left and right child, but it is giving like all the child. I can say I need all the number which is larger than this number. So that information can be passed from the parent itself. So I will be passing some value from parent to it. Okay. So parent will be passing 21 from here. Okay. So if I say 21 is passed from parent, that means I have added some number over here. It will become what? It will make the number 26 over here. Now, if I say, okay, this will be returning me 26, but it will not get added over here because I need the largest number to be added over here. For this example, I will be returning what? 26, because if I say I see for a normal DFS BFS call, what we have, like we have in order traversal, we have pre-order traversal, and we have post order traversal. But each order traversal, we might be going to our left child first. Okay, what we will be going to do over here, like we will be running our, you can say, something related to pre-order, but we will be going to the rightmost child. You can say I will be going to my rightest point, then I will be returning to my root, then I might be going to my left child. Okay, so for each child it will be like this. Okay, so if I remove all of this, so there will be something called like this. Okay, I can call this number from here, this will go here, it will go here, it will return like this, it can go here, here, then here. Okay, it can return like this. Similarly it will go here, it will go here, it will go here, it will return like this. Okay, this will return from here and it will return from here. So any call made to this number, or you can say any call made to this pointer, I'll say, okay, any call made to this pointer, or you can say root, okay, will be returning me the last value from this particular left child. Okay, so what I can do, like, okay, I will be passing something, like initially I can pass 0 0 0 to all of them, so I might be passing like zeros over here. Okay, here it will be returning me what? It will be giving me 0 for its left and right child, but the number itself will be returning from this path. So I will say, okay, 8 will be returned from here. Okay, now 8 plus 7, I'll say 8 plus 7, 15 will be returned from here. Now coming to over here, 15 plus 6 will be what? 21. 21 plus 5 will be 26. Okay, Now it will be returned over here. That means 24 plus 26 will be what? 30. 30 will be returned over here. This number will receive 30 from its parent. This number, like this number 5, received 21 from its parent. Okay, this will be passing 31 over here. Okay, so this will be passing what? 31. This will be passing me again 31. Okay, this will be again passing me 31 because I will be doing my right child operation first, not 31 here. So my bad. I will be passing 30 to the last first. Okay, so I will be passing my 30 at last. Okay, I have 30. This is 30 to be passed. Now it will be adding 30 to this right child. Then it will be processing the remaining child. Like, okay, I have processed my rightest child. Then I will be passing my root. Then I will going to the left child. So if I say, okay, it will be summed up, it will be giving me 33. 33 will come here and it will be added over here. So this will give me what? 33 plus 2, it's 35. Okay, it will come here, it will be added over here. It will give me what? 36, and it will be returned from here for any of the upcoming child. So this is what, like, very basic example we have. So for each child, we will be passing what? Parent will be passing us value. Okay, parent value will be passed. So if I say for a normal root, suppose I have some root like this, I have some value like this. I might have its right child, I might have its left child. Okay, so this is our right child, this is our left child, and it is parent. Okay, so this will be passing me some value. So I'll say, okay, pass some value. Similarly, it will be doing the operation first. Then it will be returning me what? Right child plus value. Similarly, it will be doing some operation. It will be doing what? This is some value plus right child. Okay. For this, it will be what? It will be left value. So if I say for this particular case, it will be left value plus our parent's value plus the right value. Okay, so anything passed from here, including the left child value and the value coming from the right child. So if I say, if I have any parent like this, okay, I have one, or let's say like it is 2. Let me make it 2. So this is 2, this is 3, and this is 1. Okay, so initially I'll say, okay, I'll start with 0 from here. So I'll say, okay, 0 came from here, 0 will go from here, because I will be processing my right child first. Okay, so it will go like the parent is coming. Okay, so this is equals to parent, equals to 0. Let me say, okay, I have my parent equals to 0 for now. Parent is passed as 0 for now. Now this will return me what? It will give me its value. So I'll say value plus whatever come from right plus whatever come from left. Okay, so I have value from here, left value, then right value. It will be returned to its previous, like you can say parent. So parent will be getting this value. Okay, again it will be adding up the parent value as well, whatever he is receiving. Okay, so for now I'll say parent is giving its 0 over here, it is passed over here, this returned me 3. So if I say, okay, it's right child, I'll say right has been returned 3, parent already has 0, it is having its value. So I'll say value is equals to 2 for here, so it is having a value over here, and now we will be processing. So this value become parent to it. Okay, this value become parent to it because it is the left child. So I will be passing what? I will be passing 3 plus 2 plus parent to it. Okay, so if I say anything coming over here, so suppose this was a root, so what I need, okay, this is my rightmost child, it will be returning me this value from here. That means right child value, okay, left child value, its value. So if I say, if anything coming over here, if this is my root, and if it is has made any call to it, okay, this made a call with 0 value, so this need a value what? The value of a node, okay, plus right child value plus left child value plus the parent value whatever is passed. Okay, so parent has passed 0, right child have 3 and left child have 1 and this node itself have value 2. So total will be passed over here is 5. Okay, the sum of all of them. So let me show you with example like how we gonna be doing this question. So by seeing the code, you will get easily what I'm trying to say. So I might be having some DFS function. So I will be doing some DFS call. I might be passing my root and I will be passing my parents value. Okay. So parents will be passing something. So initially I can say, okay, I will pass 0 or let me pass this in a function itself. So here, if I say if my root become like I don't have any root, so I'll say if not root, that means I need to return what? 0 from here. So I'll return 0 from here now. Now, for every right child, okay, so I'll say I might be having some right value, okay, right value. So I'll say, okay, right value, let's say right value. It needs to store all its right child. So for each of this call, like we will be making a sub call, like we want to get the rightmost child. So I will be calling this DFS function again, DFS function. Okay, I need to go to my rightest child. So I'll say okay root dot right. So it will go to the rightest child first with the root the parent's value. Okay, the parent's value, the initial value, whatever has been passed at first. Okay, it will return me some value. I'll store the current value. So I'll say okay node value. This is our node value. We need to store it over here. So I will be using it in the further call. So I have node value, which is what? This is root dot well. Okay. Now I need to have my left child value. Left child value. So I'll say okay left dot value will be what? I will be doing a DFS call for my root. You can say left child with, or let's say like before this I need to update my current node value. Okay, so I have my root. So root will be receiving a value. So root dot value will be what? It will be our node value, whatever root node we have. This the current, you can say current root value. I need this value, so I have stored it over here. So I have my node value, the current node value, and I might be having my parents value. Okay, parents value plus I have my value received from the right child. For a particular node, it might be having a right subtree. If it is there, it will return some value. Otherwise, it will give me 0 for now. Okay, so let's say this returns zeros. Now I am doing two calls. Okay, the right child will have parent as zeros initial call. It will store the current value and it will update the value of the current node with the rightest value coming from the right child. Now I need this same value. Okay, so what I will be doing, like I will be passing my same value. I will be storing my current complete value to the child, which will be stored at the, you can say, rightest child. Okay, that means I might be having my left value somewhere stored, where it will be stored, like okay, so I'll say now this value, so I need my current root value, or let's say, yeah, we can say okay I need the root dot value. Okay, root dot value will have what? Root dot value will have my current value. Okay, so root dot value has been updated, so I need this node value. Okay, I need to pass this whatever has been updated. Okay, this has been updated plus the right value, like anything coming from the right will be added over here, and plus the child value, like the parent value. Okay, parent value, because I have updated this value, it will be overwrite two times. So let's say like for every child I will be storing its parent value. Okay, whatever coming is from the right and the coming from the parent child. So this is node value, this is a parent value, and it is a right value. Okay, so this is value we have. Now every time after summing up this all, we might be having the last value. What? I will be having my right value, I will be having my node value, the current node value, not the sum up value. Okay, because it will be giving me two times. So let's say okay left value and right value and left value. Okay, so this value will be what? Whatever we have stored over here. So let's say like I have my left value, I have my right value. Okay, So this will be returned to its parent child. Okay. So this call will be made initially from where? So I'll say, okay, I have something like, let's say the DFS call will be starting from root. So I'll say root. Initially it will be passing 0. And at last I will be returning my root because I'm just updating the value in place. Okay. So let's compile this code. Let's see whether it is running fine or not. So it is saying root is not, write is not defined. So this write is write dot value. Okay, whatever is received from the write child. Let compile this code again. So again write not defined. Where? Okay, here also it's write dot value, like write child value. Okay, whatever we have stored. So let me compile this again and let's see if it is running fine or not. Parent is not defined because it's parents. Similarly, yeah, let's compile again. So many spelling mistakes. So again, it's same mistake. No right dot value. Okay, the right child value, whatever is written, and it's running compiled. Like it's compiled fine. Let's submit this code and let's see whether the code is running completely fine or not. So yeah, that is fine. Yeah, the code runs successfully, and we have the time complexity, like whatever the size of tree is there, like number of nodes you can say. So in the worst case, it can be a screw tree, so it will be order of, you can say, the nodes of the tree. Otherwise, if it is a balanced tree, it will be the height of a tree. And for similarly for recursive call, you can say for the stack, it will be using the height of tree as a space complexity. So yeah, that's all for today's. Thanks for watching.